Okay, we're going to take a look at the 2016 number 3 non-calculator question. I'm going to quickly peek over at the problem for a second. And I already see a graph on this page. I know that most likely I'm going to be drawing a number line graph, including f prime and f double prime. Ooh, excuse me, f double prime. Each will tell me things about f. I just have to check to see what they give me and what I'm looking for, and I'll determine my information based out of there. I think they're going to ask me a lot of things about is this a max or is this a min. Remember to follow our definitions for when things are maxes and mins by saying what the slope is and then it changes in those intervals. Okay, let's take a look at the first problem. Figure above shows the graph of the piecewise function f. For -4 to 12, the function g is defined by that function right there. So they're asking about g, and they want to know if g has relative maximums, minimums, or neither at 10. As soon as I hear max and mins, I know I need to see what the graph of g prime looks like. So I'm going to take the derivative of this function, and g prime of x would be equal to, this is a drop the top problem. Oh. So the derivative of g of x would be equal to f of x. Okay, so this is one of those kind of tricks they're going to do here. I know that if I want g prime of x, that is the values of this graph, because g prime is equal to f, which is the values of this graph. So I'm going to make a little number line graph. Make our number line. Okay, so is there anywhere where I'm going to write f and g prime here, which will tell you about g. Is there anywhere where the values of this graph are 0? And I see 1, 2, 3, 4 points where the values are 0. So that's -2. I might be doing more than I have to. I'm going to put them all in anyway. 6 and 10. The values all there are 0. The values before that are negative. The values are then positive. Values are again positive again. And the values are negative between 6 and 10, and after 10 the values are negative. That tells me my graph goes up and down. Whoop, who did that? I'm blaming Josh for that one. They go down, then up again, then down, then down. So I have a min here, and I have a max here. So they asked me, does g have a relative minimum or a relative maximum or neither at x equals 10? So I can say for a, neither. And they can ask me why. I can just say see chart, but I think it's better to add a little extra piece in there. And you can say the slope, you can say f prime of 10 equals 0, but does not change signs. That's enough to indicate that that graph is not a local max or a local min. So the next part of the question, part B, says, does the graph be a point of inflection? To look at the point of inflection, I need to see g double prime. Well, g double prime related to this graph, if g prime was f, then g double prime is equal to f prime. That means the slopes, g double prime is the slopes of this graph. So I'm going to do that on a different page. Here we go. Let's go g double prime and then g, which is the same as f prime. Is there anywhere where the slope of this graph is 0 or undefined? Well, I don't see any zeros, but I see it's undefined at 4. It's undefined at 2 because I have cusps. Undefined at -4. Who said 4? I wrote 0. 0, 2, 4, 8, and 10. So the slopes are undefined there. Okay, now, are the slopes positive or negative Before 0, the slopes are positive, then negative, then positive, then negative, then negative again. Oh, nope, between 8 and 10, they are positive, and then negative after 10. So they want to know, does it have a point of inflection at 4? I did more work than I had to, just so you could see it all. Right here, does it have a point? And the answer is yes, because G double prime of 4 is undefined and changes from positive to negative. And that's a good description on that problem right there. Okay, so the third part is asking me about values of the graph, minimum values and maximum values on the graph. And values of G are going to be the integral of this graph. So before I even get started, I'm going to find some areas under the curves. So it looks like to me from here to here, this is 4. So the area of this triangle here is 1/2. It's hard to write with this, sorry. 1/2 4 times 4, which is equal to 8. The area of this one is 8. The area of this one is 8. The area of this one is negative 8. The area of this one is negative 4. And the area of this piece is also negative 4. That's what I'm moving from left to right. So they want me to find values of g of x. Well, I'm going to make a table of values, and I'm going to use all these critical points along the line. X and g of x. So remember, when I have a problem with a variable in the exponent, it's easiest to find g of 2. So that means that g of 2, when x is 2, y is 0. So that means right here, the value of g of 2 is 0. It gives me my starting point. And now I can go up. And I'm not going to find small parts. I'm just going to do the big parts and see. So I know the value of 6 is going to add this area of 8 on. So that goes up to 8. Then to get to 10, I'm going to subtract off 8. It's 0. Then to get to 12, I'm going to subtract off 4. So we get to negative 4. When I go backwards, I have to do the opposite of what it says. Okay? And there's a couple ways to think about it. To go to negative 2, to go from 2 to negative 2, I'm going to think about subtracting 8, which brings me to negative 8. If you don't believe me, let's start at negative 2 and move to 2. If I move from negative 2 to 2, I'm adding 8 units on. Does that make sense? If I start here and add 8 units on, I end up at 0. So that worked. And then at negative 4, wherever I'm starting from, I'm going to add 4 on, so I'm going to go to negative 4. Let's see if that makes sense. If I started at negative 4 and subtracted 4, as I move this way, I'd get to negative 8. So is there relative max and relative min? The relative max, you can just mark it like this. This is the max, and this is the min. And you can just write C chart. So on all these problems, you can see I'm either doing number line graphs or I'm finding integrals under the curve. Okay, so the last part of this problem asks for intervals for which g of x is less than 0. So I'm going to look at my chart here. G of x is less than 0 in this interval right here between negative 4 and 2. And it's also less than 0 after it drops below 10. So the two regions are between x equals negative 4 and x equals 2 and x equals 10 and x equals 12. You can write in whatever formats you want, but that format is fine. So once again, to think about this problem, I'm going to do number lines when I'm looking for information about minimums. Does it have minimums, maximums, or points of inflection? When they want me to find values, I'm looking at the integrals, and that was the information I used to solve that problem. Okay, that's one. We're going to work on a couple more number line graphs and charts tonight. Take care.